Hi everybody, Rich Alverson. This is ITS128. It's Thursday, second day of class, and we're going to cover, I think we're still in chapter 1, so let me share my screen. Share this one. All right, let me pop this up. Here we are, 128. Let me put this down here. Okay. So today is the January 10th. It's Thursday, January 10th. I just got to fix that. And one thing I wanted to point out is that it turns out that this is not a day and this is not a day. So, you know, it's Wednesday, no, Thursday, May 2nd is the last day. And then after that's finals. So I just want to point that out. So I don't need to have this on anymore for now. And so let's look at, we are still in chapter 1. So I'm going to finish covering chapter 1. I do have an assignment that I have for all of you. And, right, and there's a quiz also. So if we look at let's look at the assignment first, okay? And then we're going to go back to chapter 1. I'm going to go through the chapter, and we will make sure that we cover everything that you need to do for this simple little assignment. The assignment is actually, if you look in the back of your chapter, back of chapter 1, and you look at some of the problems in there. There are about 4 of them, and this is the only assignment where you're just doing some calculations, and you're going to answer these questions, and you're just going to write the answers down here, and then you submit them, and I'll just look at them, see if you got them. Okay, so we're learning about the binary number system and how the binary number system is used in computers. We're learning that in this chapter, okay? And we've learned that there's binary character, or there's these character codes called Ascii character codes. It stands for American something code interchange, a long time ago. And they, for representation of letters and numbers and so on, that would appear on your screen. Okay, so like the Ascii character code, the character codes run from 0 to 127, or there's sort of an extended Ascii character set from 128 to 255, and it's all the character sets. It's all the characters that you see on a keyboard, basically, and then some other ones. And so like a capital A happens to be code 65, okay, which happens to be binary, 100000001. Okay, capital B is 1000000. No, let's start over again. 1000010, and C is 1001, no, 0011, and so on. I'm just counting up in binary. So I'd like you to refer to Appendix C. Let's open up Appendix C. I've got a copy of this textbook. Vital source. Some of you have asked me if you could use the previous edition of the textbook, and that's fine. That'll work. What I am going to do is make sure that when I am covering something that is not included in the previous edition, then I will make sure to give you some sort of supplement. In many cases, I'll avoid it because the difference between I think it's the 4th edition and the 3rd edition is very little. There's a little bit of stuff, and that little bit of stuff has to do with new features in Visual Studio, mostly. And I don't care too much about new features in Visual Studio. I just care about all the real important ones, which have been around since Visual Studio 2013 or so. You get back to Visual Studio 2010, there's kind of a lot of stuff missing. Now I think I have it in here. To let me in. Let's look at my library. Let's see. This one. If you want to get the electronic version, that's just fine. If you want to rent the electronic version, that's just fine. This textbook is not necessarily a textbook that you would need to keep around. Why? Because you're probably this 128. You're probably all going to take 148 also. We want to try to get you through both those courses. After that, you have to decide whether you want to continue programming. But you really don't get the full picture, the full idea of programming, even if you're not going to end up being a programmer. It's really helpful if you get the full picture. You're taking 128 and 148. So that's what my goal is. And the 148 textbook is a much better textbook to keep. It's a cookbook, and it's really fat. It's not that expensive, and it's got everything that this one has in it, and a whole lot more. And the stuff that's in this textbook is in the textbook for 148 in like about the first 4. It's real condensed, so it's just to the point. And right now I'm teaching 148, and we're buzzing through those first 4 chapters. And they've all had this course, and it's pretty good. They're all just refreshing. We're all just refreshing our memories. So that's what my point is, that renting the textbook is just as good. Let me see where we are in chapter 1, and we are at the end. Okay. Oh no, I was going to look for Appendix C, so-called Appendix C. Appendix C, Ascii and Unicode characters. Okay, Ascii character set. So these are what this is character code 0. It goes 0 all the way up to 127. Okay, so it's the basic Ascii character set, and so that all fits in 2 bytes, or no, in 1 byte. Actually, it's only 7 bits. So the 8th bit is not even, the most highest order bit is not even used in this character set. And these are what all the codes are. I was talking about capital A. Capital A is, 65, as I said. And the numbers are here. The numbers are 48 is 0, 1, 2. It goes up like that up to 0 through 9. Up 0 through 9. 9 is 57, and then we got a colon and a semicolon and the less than sign, the greater than sign, so on. Then we get into the capital letters, and then higher up are the lowercase letters up here. So and when you're sorting things alphabetically, it just uses this character set. It just uses, and so if you have like a bunch of words, and they're words that are represented in ASCII, and those words happen to have some numbers in them and some digits in them or something, and there's uppercase and lowercase, you're going to see the sort order be based on these ASCII character code representations. Now, in this assignment, the first thing we do is refer to the Appendix C and determine the ASCII character codes for your first name. Okay, and I've looked at everybody's first name. It's not that long. Some of you have longer first names. Don't worry too much about that. It's easy. I think some of you have spaces in your first name. Some of you have spaces in your first name. Well, a space is 32. So if you have a space in your first name, there should be 32 someplace in the middle. Otherwise, you can choose uppercase or lowercase. Why don't you make the first letter uppercase and the remaining characters lowercase? I'll just be able to look at that and see. I probably won't I probably won't mark off anything if you make them all uppercase or make them all lowercase. Okay, so that's the first question. The second question is convert the first 4 character codes of your first name into their binary representation. Okay, so you know, for those of you that have longer first names, now it's okay because you only have to do the first 4 characters. So what I want you to do is, like, for mine, it's my first 4 characters of my name are written R-I-C-H. So I would do an R, which is 82, and then I convert 82 into the 7 1s and 0s that represent 82. And it's actually pretty easy. Well, anyway, the book shows us how to do it. There are various ways you can do it. Just realize you don't know hexadecimal yet, but that's okay. You do it in binary. So yeah. So we'll see how to do it, but it's just a bunch of divisions. It's a bunch of dividing by 2. So you divide by 2, and if there's a remainder, you keep the remainders are only 0 and 1. Divide by 2, you keep the remainder. Take the result, divide by 2 again, and keep the remainder. Take the result, divide by 2, and keep the remainder. And you just have to get the order. If you're going left to right or right to left. And then you can compute it back again by multiplying by 2 each place. So we'll see that. We're going to cover that today. Okay, so that's that part of the assignment. Third is, suppose I ask you. Okay, so now we're off on something else. Okay, we're off on designing a form. Suppose I ask you to write a program to enter your total quiz score, and I'm going to say it's an average of 100. Okay, so let's say you add up all your quiz scores. Let's go back. Let me go to Gradebook Classic. Okay, so you're going to have assignments worth 40%, and you're going to have exams as the midterm and the final worth 30%, and you're going to have all the quizzes added up for 30%. Now, suppose they're somehow scored so it's a 100. So you're going to have some score for your assignments that are between 0 and 100. It's going to probably be more like between 50 and 100. My wife's a math teacher, and she explained to me that the current scoring grading system is highly unfair, because if we actually were to use just the percentage numbers, then you know, somebody can get an F on the midterm and get an A on the final, and it averages out to an F. Why? Because if they get a really bad F, like it's 2, and they get a 100 on the final, then what does that average out to be? About 51? 51's still an F, okay? So that's ridiculous. So it's going to be like you hand it in, you'll get like 50, okay? So or 60, you'll get that'll be the bottom, and then after that, you're going to build up from that. So it's not like I'm being like really generous, giving you half the credit for just like handing it in, but I'm being fair, okay? And a lot of math departments, my teachers in a math department, they've moved to that kind of a system, and other places do. Of course, it just matters the school you're at and all that. But some people have switched to a 0 through points. You get 0 points through 12 points. 12 points is an A or A plus or whatever. And then if you think about it, there's like 12 different steps between, you know, F, D minus, D, D plus, C minus, and so on. It's like 12. And so that's another way of doing it. I'll stick to percentage plus minus and score it that way. So let's say, you know, you're done. You got all these scores. You got, you know, for your assignments, you got a total percent for your assignments, a total percent for your exams, and total percent for your quizzes. And then you have this assignment here. And so I want you to, so if you were to write a program where you enter in the quiz score, a number between 0 and 100, and then in another text box, you enter in the exam score to 0 to 100, and then total assignments, you enter in the third number in text box, and then you click on a button, and what appears is the average. Okay, somewhat, and maybe a label. It's got the average here. Okay, so I ask you, how many input text boxes would your form need? I just told you. What other input would your form need? I told you that too. Input. You gotta say, okay, I've entered my number now. Do it. So that's another input. how would your program calculate the total score? Okay, so now there's a little bit of math here. You got to think about it, and feel free to consult your, to work, talk to each other if you're stuck, and if you're someone who knows the answer and someone's talking to you because that other person's stuck, don't, you can help them. Don't hand over your answer. You can help the person understand. What it is, and it's easy. You just take the quiz score multiplied by what's 30%? It's 0.3. What's 40%? It's 0.4, because 0.3 plus 0.3 plus 0.3 plus 0.4 equals 1, and so 100 times 0.3 plus 100 times 0.3 plus 100 times 0.4 is the same as 100 times 1. Well, it's not 100, it's an average, okay? So the average is weighted 30% for the quiz scores, 30% for the exam scores, and 40% for the assignment scores. So the expression is simply exam score times 0.3 plus quiz score times 0.3 plus assignment score times 0.4. And you add it all up, and that's the number. Okay, so you have an expression which has got like 3 multiplications in it and 2 pluses in it. And then it equals some value which you display back out to the user. So that's this. And you should be able to write an expression, okay? This is 128. You have to have some kind of math for this class, right? Yeah, okay, all right, good. What would the output of the program be? Okay, so you can say, it's a number between 1 and 100, whatever. Okay, and just write the answers down here. So that's the first assignment. It is due, I don't tell you. Okay, I don't tell you when it's due. All right, it's due, it's due the Friday of the following week. Okay, so I give assignments on 1 week, and they're due the Friday of the following week. Now, what that really means is that, okay, and during that time, I'm going to be covering in class everything you need to know to do the assignment. I'm not going to cover everything in one day. It'll be spread out over the time. I might do a piece here. I might do a piece there. I might start the longer assignments. I might start it in one class and finish it in the next class or something like that. If you're stuck, you just keep on paying attention in class, and you'll eventually get to it. Remember, we're recording these videos, so you can always go back and revisit something. And so, let's see, I forgot. I lost my train of thought. Anyway, so the assignments are due Friday, the Friday after the week they're assigned, and then and during that time, you can resubmit your assignment, as many times as you want. Okay, so you might resubmit your assignment, in the beginning, just because you do it. I had a student last semester that he just loved this class. Okay, so he would submit the assignment right away. Okay, he'd do it. Oh, next assignment, get on there and do it. And then he would do it one way. And then in class, sometimes what I'll do in class is, if there's enough time and it's a short enough assignment, I might do it one way at one time, and then I might say, but there's another interesting way we can handle this, and I might do it another way. And sometimes at the end I might show you some sort of fancy stuff, how you can take shortcuts. And so he would oftentimes submit it again, and just because he want it, it's pretty easy. The stuff's pretty easy. Okay, and then after Friday, let's say you don't hand anything in after Friday. It's okay. You can still hand it in all the way up to like the first day of finals. Okay, for these early assignments, it's going to be like the first day of finals. Okay, the assignments at the end, the drop dead date will be later in finals week. So you can submit it. You can still submit it, but you can only submit it once. Okay, yeah, big deal. It's the same as your quizzes. It's the same kind of thing. You've got due dates for your quizzes. You can take them as often as you want until the due date. And in fact, with quizzes, it's nice because you can go back and see what your score is. And if you don't get all the points, you can just go back and take the quiz again. It's going to keep your highest score. But then after the due date, if you've already done the quiz, you're done. If you haven't done the quiz and it's after the due date, you can still do it, but you only get you only get one chance. Of course, that's better than no chances, because the no chances is a 0. Yeah. So. And the quizzes are just not that hard because they're all open book. Take as much time as you want, and you should be able to get them all right the first shot. Sometimes you might get one thing mixed up with something else, and then you go back and you get the score. Like, oh, and you look more closely, you can see. So that's how these assignments work. So the due date is January 18th, which is like this day, and then you got you know, I think you might. I think I might give you one more day to resubmit or something. But then after that, everything's got to be in. Like for this one, I think it's probably something like this is the first day of finals, the 6th. But like the last assignment, you'll probably have until the 12th or something. Why? Because at the end, there's going to be several of stuff. I don't know how many it'll be. I hope not too many. But you know, people are gonna. There's gonna be some of you that are gonna flood up. You're gonna get them all done at the end. You know, you're gonna be jamming the last week or something, and you know, handing them all in. And so then I got all these assignments. I got to grade. I got to grade them. You know, I can't just not grade them. So that's why I got to spread out these due dates here. But you know, the last assignment will probably be hard, and so I want to give you as much time for that as possible. All right, so let's go let's go stuff 4.3. Let's go look at the, let's go cover what is in the textbook here. It's this one here. So we are in chapter 1. Oh, there are slides for this. Have I gone over the slides for this already? I bet I did. Yeah, let's see. $36. Oh, here. Okay, there. Okay, this helps. Yeah, I've gone over these slides before, haven't I? So let me just go over the important ones again to help us do our assignment. All data stored in the computer is converted to a sequence of 1s and 0s called bit. Computer's memory is divided. Okay, storage location 8 bits make a byte. 1s and 0s. Okay, Ascii A is 65, which is 100 0001. So you can think of it as really like 0100 0001. This kind of, by putting a little space there, it kind of separates it easier. You can see it's 2. So you can see there's a half of a byte. You probably learned this in 101 or something. Half of a byte is called a nibble. And so a nibble is 4 bits. And 100, this is a binary number. And it doesn't convert easily to decimal numbers. To convert this to a decimal number, you need to do, let's see if I can do this. It would be okay, so this is like the 1's place, the 2's place, the 4's place, the 8 place, 16, 32, 64, 128. Okay, so those are the positions, okay? That's just like if this were a decimal number, This would be the ones place. This would be the tens place. This would be the hundreds place. This would be the thousands place. This would be the 10,000th place, the 100,000th place, the millionth place, and the 10 millionth place. So in decimal, this would actually be 1,000,001, right? 1,000,001. So this would be 1,000,001 in decimal. Well, in binary, it's only 65. Why? Because when we compute this, it's actually 0 times 128 plus 1 times 64 plus 1 times the 64 plus 0 times 32 plus 0 times 16 plus 0 times 8 plus 0 times 4 plus, am I doing this right? Plus 0 times 2 plus 1 times 1 equals, of course, this is 0, this is 64, 64, 64, 64, because anything times 0 is 0. 64, 64, plus 1 is 65. So that's how you convert decimal to binary. I mean, binary to decimal. So, and to convert decimal to binary, you go, let's see, let's try this. 64, okay, so it's 64. So we start with 64. This is gonna be hard because I don't know how to keep track of them. I'm gonna change this to 66, okay? I'm gonna change it to 66 just so I can keep track of it. And you'll see why I'm doing this. So it's the B is 66, which is converted to this 1, 0. Oops. Okay, so that's binary 66, and so it's and this is 1 and this is 0. Okay, you got that? So what we do is it's 66 divided by 2 equals 33 remainder 0. So let's put a 0 someplace here. Let's put a 0 down here. 0. I'll make it red or something. Red. I'm gonna, just to make this easier on myself, I'm gonna get rid of this space here so I got more space. All right, so so 66 divided by 2 is 33 remainder 0. So put a 0 there. Now 33, I can put this over here. 33 divided by 2 equals 16 remainder 1, right? 16 times 16 plus 1 is 33. So let's put a 1 here. I think I've got this backwards. I think I put the 1. Okay, now I know I have this backwards because, okay, so so this is the lowest order bit. The first one you get is the lowest order, so the 1 goes on this side. So this 1, so each time we do a division, we're adding digits onto the left side of the binary number, and when we've got all the way to 1 or to 0, then we know we're done. So 33 divided by 2 is 16 remainder 1. 16 divided by 2 equals 8 remainder 0. Let's put a 0 here. And 8 divided by 2 equals 4 remainder 0. So let's put another 0 there. And 4 divided by 2 equals 2 remainder 0. So I'll put another 0 there. and 2 divided by 2 equals 1. Remainder 0, 0. And 1. Get rid of this crap. And 1 divided by 2 equals 0. Remainder 1. Look at that. Equals 0. Remainder 1. And put a 1 there. And now we're and now we're done because we have 0 and we're done. Go down to 0. So what is this? This is exactly what we started with. This is 60. This is what we had before. So 1000010 equals 60. This 66. Yeah, 7 bits, because the top bit is always 0 in this, because it only goes up to 127. See, so this is always the case, because there's never an 8th bit. Yeah, because this is a simplified ASCII. There's, if you look at them. So here's an ASCII character set. This is pretty good because it, okay, so this will help us see what different formats of this is. So this is what we saw earlier. This is the decimal, 0 through 631. We're doing 62. Oh, 65 we were doing. 65 is A, 66 is B. 66 is B. Now, hexadecimal is base 16. You probably remember that. 66 is decimal, and this is, okay, so let's go back to this. We've got, excuse me, binary is 01000001. Now, as we may remember from hexadecimal, is let's do this. I'll put some space over here, and I'll put this down. Okay. So hexadecimal, it's base 2, and base 16. Okay, and base 2 and we're comparing base 2 and base 16, and so base 2 numbers, it's like double spaces. 0000 is hex 0. 0001 is hex 1. This is boring. 0010, 0011, 0100, 0101, 0110, 0111, and then we go higher than that. I mean, just kind of dumb to do it this way, but two, 3, 4, 5, 6, 7, and these are 1, 1, 1. This is 8. 9. And in hexadecimal, we can't use 10 because 10, it's base 16. So 10 would be 16 times 0. So we have to come up with some new characters. And we use A, and we use B. You remember this from some class you took before. C, E, E, and F. Okay, so now we have these new characters that can replace. So we've got one character here that can replace all 4 binary digits, and it's complete. Okay, it goes all the way to the top. You know, when you're using 4 digits, 4 binary digits, there's 16 possibilities, and it's all 16 of them, 0 through 15. This is like 10, 11, 12, 13, 14, 15. Okay, so this is a compact way to represent binary. You can kind of think of it that, because it's easy to switch back and forth between hexadecimal and binary. You can just memorize it, and then you know, or you can figure it out pretty easily. So when we look at this, yes?
Yeah, sorry, I think about that. So would hexadecimal be more efficient than binary?
Well, yes, it's more efficient for us to write. It's more efficient when you're programming. If you're programming down at that level, there's some, but really it's the same. It takes up the same amount of space because it's only our representation. You know, it's really four bits there, but we're you know, combining them up and making it easier. And that's why in this table we don't see the binary, but what we do see is the hex. So we have A here. Okay, A. It's hex 41. Well, what's 41? It's 01000001. Okay, and this B is hex 42 is 01000010. Okay, that's exactly what this is here. Where's 66? 01000001. This is hex 4, and this is hex 2. Okay, this is hex 4, and hex 2. Now, octal, we don't use octal anymore, but we used to use octal a lot back in the old days. It's just 3 of them because it's base 8. So it's 0, 1, 2, 3, 4, 5, 6, 7, and then that's it. And it's only just 3 digits, you see. So we clump them up in 3s. So in this case, it'd be, this is the lowest order digit, this is the second lowest order digit, and this here is the 3rd lowest order digit. So it's in octal, it's 1, 0, 2. That's what this is in octal. And if you look at here, we see it's 102. So that's also a more efficient way. And in fact, in the old days, you know, they always were looking for efficiency, and so they did octal because they weren't yet comfortable with adding a bunch of characters to the character set, for hex. And back then, the first and so you know, now everything is byte oriented. Like, you know, the 32-bit Windows is 4 bytes, and 64-bit Windows is 8 bytes, and the Ascii character. Back then, because we didn't do hexadecimal, it was octal. And the first machine I worked on was writing Fortran programs on a 15-bit machine. So it was, you know, there's 5 octal characters and 15 bits, and so we would you know, and so that was just fine. You know, and then we got bigger and bigger, and we realized it was more efficient. People became more comfortable with those extra characters at the end, and so now we always use hex, and we don't really use octal anymore. Okay, so let me just go back to the assignment. I want to make sure I'm covering everything here. Okay, so your first name, and then convert the first 4 characters to the binary representation. Okay, okay, so mine's is okay, Rich I-C-H. So what's R-I-C-H? Well, it is R is, capital R is 82. So let me go to 82 to, is this decimal? Yeah, it's decimal. Ooh, I'm gonna cheat. No, I'm not gonna cheat. But you can figure out how to cheat. I'm just gonna do it this. I'm gonna do it the way I ask you to do it. But with this table here, no, with where is it? Oh, this one. You go search the web, you find a table like this, and look, it gives you the hexadecimal. Okay, so once you have the hexadecimal, it's easy to convert to binary, right? I just showed you. So if you want a shortcut, do that. All right, so 82, what's I? What's I? I'm gonna go to the I, lowercase I, let's do lowercase I. Oops, where is it? Oh, it's down here. Yeah, lowercase I guess might be a little harder, so you might wanna, oh, of course, if you're doing the shortcut way, it doesn't matter. But if you're doing lowercase, let's do lowercase I though. It's I is 105, decimal 105, I'll put it down here. 105. And what's C? Lowercase c is 99. 99. And lowercase h would be what? 104. 104. Oh yeah, H is just before I, and look at that, 104. And so okay, so that's okay, so I could go I could do ARD also. Okay, that's the rest of my name. Anyway, so convert the first four characters of your first name to their binary representation. Well, you know, you could, instead of you can go look up R and figure out the hexadecimal representation is, and just convert those hex characters to their binary equivalents. But I'm going to do it the hard way. Do it the way I would like you to do it if you could practice. 82 divided by 2. 82 divided by 2 is 41, and remainder of 0. And so I'm doing 82 now. 82 divided by 1 is 82 divided by 1 is 41, so that's 0 with a 0, okay. 41 divided by 2 is 20 with a remainder of 1. So I'm going to just put over here 41, 1, 20. 20 divided by 2 is 10, remainder 0, 10. 10 divided by 2 is 5, remainder 0. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 0, remainder 0. No, 2 divided by 2 is 1, remainder 1. 2 divided by 2 is 1, remainder 0. And then 1 divided by 2 is 0, remainder 1. Okay, that's better. 1, 2, 3, 4, 5, 6, 7. Okay, so this looks like the binary representation of R, ASCII R. So by the way, what is this in hexadecimal? Let me change colors here. What is this in hexadecimal? This would be 2, and this would be 5. 52, capital R 52 is capital R 52. In hex, capital R is 52 in hex. Well, that's pretty cool. And it's 82 in decimal. All right, very good. Looks like that worked. Next, we can do 105. It's 408. Okay, the rest of the 3 is easy, isn't it? Okay, 105 is, let's do this. 105 is 52. 52, remainder 1. Remainder 1, I'll put the 1 here. No, I'm not going to put it there. I'll put it someplace else. It's the eraser, right? Why erase? Erase. Oop, I don't want to do that. I just want to erase this ink. Oh well, it's not working. Something's messed up. All right, I'll do it over. 105 divided by 2 is 52. R1. 52 divided by 2 is 26. R0. 26 divided by 2 is 13. R0. 13 divided by 2 is 6. R1. 6 divided by 2 is 3. R is remainder 0. 3 divided by 2 is 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. So the answer is 52. The answer is it's 1, 0, 0, 1, which by the way is 9 hex. 9 hex. And 1, 0, 0, okay, 0, 1, 1. 0, backwards here, 1, 1. So 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1. And so in hex, that's 9 here, and this is 9, and this is 1106. 69 hex. That's lowercase I, 69 hex. Lowercase I is 69 hex. 105 decimal is 69 hex. So that's I. C is 99. So let's do 99 over here. 99 is, we're going to do 99. 99 divided by 2 is 49. R1, remainder 1. 49 divided by 2 is 24. R1. 24 divided by 2 is 12. R0. 12 divided by 2 is 6. R0. 6 divided by 3. R0. 3 divided by 2 is 1. R1. 1 divided by 2 is 0. R1. So if we write that out, it's 1, 1, 0, 0, 0, 1, 1. 1, 1, 0, 0, 0, 1, 1. Okay? Okay, so this is 3 hex, and this is 6 hex. See what that is, all right? It's a C. RIC 6399, is that right? Yeah, 99 is right, 63, is that what it came out to? Yeah, 63. Okay, so that's C. By the way, you don't have to do this hex conversion part, but that's how you cross-check. Of course, you can just put the hex down and write the binary after that. But, okay, let's just do H. H is just before I. So if H is just before I, it would be HI is this one, right? This is I right here. So if it's one less than that, it would be 1 1 0 1 0 0 0. So H is 1 1 0 1 0 0 0, and this is 8, obviously, and this is 6. 68, which is 1 less than 69. So let's say H is, lowercase h is 68, 104. 68, 104. Okay, so so that's that. And then so this third problem is you should be able to figure that out just by thinking logically. Let's see if this thing gives us any insight. So in this program, you enter the number of hours worked, and you enter the pay rate, multiplies the two together. No, that's all it does. You enter in number of hours worked, it's a number that goes in here. You enter in the hour pay rate, $15 an hour goes in here. And then it still isn't doing anything. To cause something to happen, it's an event. All the programs we write are going to be event-driven programs, as they say. And that means that it sits idle until some action occurs, until some event occurs. And there's all kinds of events. Anything you can think of. Rolling your mouse over a label, that's an event. Now, you don't normally do too much with that. You maybe will never write a program that does anything with that. But that's just to let you know that Windows, these form objects that Windows C# or that C# has for you it's set up so you can attach an event handler to all kinds of events. An event can be the action of pressing down on a key in a particular text box. Another event could be the releasing of the key in a particular text box. Okay, so there's just a whole bunch of them. But a button, a button is only for an event occurring where you press a button. Okay, so you throw a button on there, and you're going to attach an event handler to that button. To this one, calculate gross pay. The event handler you're going to attach to it is an event handler that fires up when someone clicks this button. And the program goes and gets the number out of this number of hours worked, goes and gets the other number out of hours pay rate, multiplies the two numbers together, and gives it back to you somehow. It's not clear here how that happens, but a really easy way for it to give it back to you is just to pop up a message on the screen telling you, you made, $50 or $500 this pay period or something. And then this exit button, the only event that's associated with that is when you press it, and then it closes out the program. The program stops and the form disappears, and you're back where you were before you started the program, which is presumably Visual Studio. So that's what we're talking about here. .NET framework, the program development process, understand the purpose, design the graphical user interface, design the logic, and that's the hourly rate times the number of hours equals the amount paid. Write the code. That's about 3 lines of code. Try to run it, and it comes back and says, "Bung," you know, some kind of error, and you just tells you right there what the error is. If you look at it, it tells you the error is, you don't understand it, well, you roll your mouse over it and right-click, and it gives you more information. Visual Studio makes it really easy for you to learn programming fast, because when you make an error, it's so helpful in telling you what you did wrong, and so you correct those errors right away and you learn stuff fast. And so there's the kinds of errors. Syntax errors will make your program not run, but your program could run and still be wrong, and those are the logical errors. Those are the errors that you got to correct, because you add up the numbers and you go, oh, wait a minute, I divided those numbers. They're wrong. It's wrong. I should have multiplied those numbers. Well, the program doesn't know that you should have multiplied instead of dividing. So that's where you have to make sure you wrote your code correctly. Here's this. Do we put anything on this form? Oh, the solution files and so on. Okay, yeah, we're done with that. So 419. I got 10 more minutes here. Let me Visual Studio. When you power up Visual Studio, you're gonna have to first, you're gonna download Visual Studio for your home computer or whatever, and when you download it, you have to log in. Microsoft wants to know who you are. I think it wants to know your email address and everything. And you can use your Hawaii.edu account, or you can use any email account. And so that login that you used to be able to get the free version of Community 2027 Visual Studio 2017 Community Edition, like this one right here, has anybody noticed I haven't been breathing? My watch is telling me to breathe. Glad it reminded me.
Oh, yeah.
Oh, I'm supposed to breathe for 1 minute. Okay, so you got to sign in so you can use the computer at your desk. You just use your same login. And I've got 2 of them because I can't remember. I got 2 Hawaii.edus. I remember this password, so I'm going to use that one. See, so you can even, if you forget your password, just create another account, anyway, so this starts me up, and close this now. And so, this first assignment is, you open a new project or something. Oh, no, I guess you don't have to do this. You just have to answer the question. So it's going to be a Windows Form application. I'm just going to put this on the desktop just because why not? And I'm going to just say assignment 1, whatever. Yep. Yes, it's free. It's free. I do free as much as possible. And by the way, I don't think you would ever need anything more than community for any class here at KCC anyway, because it's, I don't think you need anything. I don't think you need professional. You actually can get professional though, if you want. I can. In fact, I forgot. I got to do this. I send all your email. If you don't have it already, I send all your email. Give all your email addresses to the guy or Tony, and then he gives you what are called, I think, Microsoft Imagine accounts or Microsoft DreamSpark accounts or something, and you can go in there and you can download because you're a student, and we pay a bunch of money so you can have this. You can download a professional version of. You can even download the Enterprise Edition of Visual Studio if you want, and you can get and that's where you can get Windows 10 version 10. If you have a Mac and you want to run Windows and you want to run Windows Visual Studio on your Mac, you engage boot camp. You start a boot camp, and then you download Windows 10 from your DreamSpark account, and then you install. So you have a Windows to install on your Mac on boot camp, Did I say boot camp? I did this. Yeah. And then, with boot camp, you just switch over, do this thing, switch over, restarts, and then boom, you're in a Windows machine, completely, it's all Windows. And then you just go and you download the, professional edition of Visual Studio or whatever you want. And when you do these assignments, you switch over to boot camp. Now there's other kinds of things like boot camp for the Mac where you can actually switch back and forth while the computer's on. The trouble with boot camp is you actually have to restart your computer, but that's what comes with the Mac. Did you have a question?
So I was trying to install Visual Studio Community. And there's like a bunch of different options what you want to download. So are there any specific ones that you have to download all of those?
I would. Is there a suggested installation or something?
Yeah, give a suggestion.
Yeah, so you do that, and then when we start trying stuff, if what you need is not there, then I think you can just download what you need there. But I'm quite sure, just as long as you can get to C#, as long as you have the C# stuff in there. But anything else you can install later. All right, it's 424. So what was the assignment? I'm gonna look at the assignment again. Total quiz scores, that's right. Okay, so that'd be something like a toolbox, pin the toolbox. You're gonna learn all this, if you can learn all this if you haven't learned it now. Oops. Toolbox, pin the toolbox, so you have it over here, common controls. So we're gonna have a, what is this? We're going to have a, it's quiz score, assignments, exams, into a text box, another text box, another text box, and a button to do it. And these labels don't really matter, but you want to have them there anyway, just so you can see assignments, score, whatever. This one can be exam score, and this can be quizzes score or something. And these are buttons where you got to add. This is where you enter the stuff in. What time is it? And then this is a button we're going to execute. Okay, so it would look like this. Well, how many inputs? 1, 2, 3, 4. Now there's this thing. The code for this. Let's say I want to create the event handler for compute, where when you press on compute, it grabs these numbers, multiplies them by their factors, and adds them up and presents the results. Where do we present the results? We can present the results in another label here. And there, since we're going to output, we want the text to say nothing, but we want to name. We want to name this thing. Here's where we name it. See, and I'm going to name this LBL result or something like that. And so now to generate the event handler, double click on compute, and the code window opens up, and right here is the event handler for this button click. I should have named the button something different, but I'm just going to do LBL result.text. That's how I write something into the text of this label. I'm going to say result. Let me just write this. Result goes here, and I'll just put that there, and that's fine. And now I'm going to run it. Run. And oh, I got errors. Oh, I forgot to put a semicolon here. See, it tells me I forgot to put a semicolon. It tells me semicolon expected on line 22. Yeah, okay, I'll put that there. There we go. Now the squiggly goes away, the error goes away. It's all in real time. Now I start it up, and kabloom, there's this form. And so I'm just going to click this, and it's going to write, result goes here. Now instead what you do, let me just close this out. Instead what you do is you'd, grab the first one, multiply it by 0.3, grab the second one, grab the third one, multiply, add them all together, and that's what will go here. That's beyond the scope of this assignment though, but we'll probably get that next chapter. Pretty easy stuff. Okay, so I have shown you how to do all this stuff. Am I recording? Yeah, it says recording. Okay. Oh, good. Okay. All right. So, so I've gone over chapter 1. We're finished with chapter 1. I've presented an assignment, showing you how to do the assignment, and so it should be pretty easy for you. And so next Tuesday we'll start with chapter 2. All right. Any questions? Okay. Thanks for watching.